NASA has a new plan to reach the south pole of the moon. And this time, they're betting everything on the only company that's proven it can deliver. The agency is partnering once again with Firefly Aerospace, which so far is the only American company to have successfully landed a spacecraft on the moon this year with their Blue Ghost 1B E1 mission back in March. Successfully reaching the moon's south pole has proven difficult, brutally difficult, for NASA and their commercial partners. Another American company, Intuitive Machines, has attempted to land there twice in the past 2 years and failed on both occasions. The Firefly Blue Ghost previously touched down in Mare Crisium on the moon's northern hemisphere, a relatively easy task compared to the rugged terrain and deep shadows of the South Pole. But NASA clearly believes Firefly is up for the challenge, and they're trusting them with at least 2 high-value payloads for this trip. Because here's the thing, the South Pole isn't just hard to reach, it's one of the most valuable pieces of real estate in the entire solar system. Deep within those permanently shadowed craters lies water ice, the key to sustaining human life and producing rocket fuel in space. And Firefly isn't going alone. They're taking 2 revolutionary rovers to map the darkness and hunt for that ice. This mission, launching as early as 2029, is just the beginning of something much bigger. From mysterious missions to the far side of the moon to solving geological paradoxes and the dawn of lunar mining, we're about to witness the transformation of the moon from a scientific outpost into a bustling economic frontier. Let me show you how it's all going to happen. Blue Ghost will carry a pair of cutting-edge lunar rovers to the South Pole, each designed to tackle one of the most hostile environments in our solar system. The first is called Moon Ranger. It's being developed by NASA's Marshall Space Flight Center in collaboration with Carnegie Mellon University. Moon Ranger is about the size of a carry-on suitcase, and it's designed to autonomously explore the lunar South Pole in search of water ice. The rover's stereo camera system will build 3D maps of the lunar surface that allow it to operate with 100% autonomy, even when there's no communication back to Earth. Think about that. This little rover will be making its own decisions about where to drive, which rocks to avoid, and where to search for ice, all while navigating terrain that's claimed other missions. The second rover on this mission is being developed by the Canadian Space Agency. The as-yet unnamed vehicle is a similar luggage-sized 4-wheeled platform that will seek out new discoveries on the lunar surface. It's the Canadian Space Agency's first major contribution to lunar exploration outside of their famous robotic arms. This rover will also be hunting for signs of water ice at the South Pole, but it has an additional mission: measuring radiation levels and temperature changes in this extreme environment. We need this data if we're ever going to send humans to work in these regions. But here's what's really cool about the Canadian rover. It uses solar power, but it also has a battery large enough to dive deep into permanently shadowed craters and operate in total darkness for up to an hour. These permanently shadowed regions are where we're most likely to find large deposits of water ice. Sunlight hasn't touched the floors of some of these craters for billions of years, making them some of the coldest places in the solar system, cold enough to trap water as frozen deposits. This also means that, unlike most rovers, which shut down during the 14-day lunar night, this one should be able to survive the darkness and reactivate for another lunar day of exploration once the sun returns. The Firefly Blue Ghost lander itself isn't just a delivery truck. It's carrying 3 sophisticated scientific instruments that will conduct groundbreaking research. First is the Laser Ionization Mass Spectrometer. This instrument is going to use a robotic arm and a scoop to collect samples of regolith material from the lunar surface. Then it blasts that material with a laser to break it down and get a super detailed look at its composition, down to individual atoms and isotopes. This kind of analysis tells us not just what elements are present, but in what ratios and forms. It can distinguish between different isotopes of the same element, which reveals information about how and when that material formed. Just like previous American lunar landers, Blue Ghost will be equipped with NASA's stereo cameras for lunar plume surface studies, part of their ongoing research into how spacecraft interact with the light, dusty regolith that covers the moon's surface. When a spacecraft lands, its rocket engines blast this dust in all directions, creating plumes that can damage nearby equipment and obscure visibility. Understanding this phenomenon is critical as we plan for more frequent landings and eventually permanent bases. And like other landers, this one will carry NASA's Laser Retroreflector Array, which basically allows scientists to shoot the lander with a laser beam from Earth. That beam bounces all the way back, providing a super-accurate location reading for where Blue Ghost ends up. This technology has been used since the Apollo missions to measure the exact distance between Earth and the Moon, and it's still providing valuable data about how the Moon's orbit is changing over time. This South Pole mission is scheduled for launch as early as 2029 and will be the most ambitious test for Firefly so far. But it won't be their only trip to the Moon this decade. In fact, NASA had already selected Firefly for additional missions even before Blue Ghost 1's successful landing. The next mission is set to launch next year and will send Blue Ghost 2 to the far side of the Moon, also often referred to as the dark side, though it's not actually dark. It's just not visible from our perspective on Earth, but it is very different from our familiar near side. Why go to the far side? Because it offers something incredibly valuable to astronomers: silence. Earth is noisy, electromagnetically speaking. We're constantly broadcasting radio signals in every direction: TV, radio, cell phones, Wi-Fi, radar, satellites. All of that creates a deafening background of radio interference that makes it nearly impossible to detect the faint radio signals from the early universe. But on the far side of the Moon, you're shielded from all of that. The entire bulk of the Moon sits between you and Earth's radio cacophony. It's the quietest place in the inner solar system. Blue Ghost 2 will deliver a European communications satellite called Lunar Pathfinder into orbit around the Moon before heading down to the far side region. Once there, it's going to deploy a payload called the Lunar Surface Electromagnetics Experiment Night, or LUCI-Night. This experiment is designed to detect radio waves from the cosmic dark ages, the period after the Big Bang, but before the first stars formed. These are some of the oldest signals in the universe, and they've never been detected before because Earth's radio environment makes it impossible. By setting up shop on the far side, LUCI-Night will have an unprecedented opportunity to listen to the universe's earliest whispers and potentially revolutionize our understanding of how the first stars and galaxies formed. Then, in 2028, Blue Ghost 3 will embark on perhaps the most intriguing scientific mission yet: a visit to the Gruithuisen Domes. These are strange geological formations on the Moon, two large dome-shaped mountains that rise about 1,000 meters above the surrounding plains. They were discovered in the 1960s and have puzzled scientists ever since. Here's the mystery. Spectroscopic analysis suggests these domes are made of silica-rich volcanic rock, essentially granite or rhyolite. On Earth, this type of rock forms through a very specific process that requires two things: tectonic plate activity and water. Neither of these things exists on the Moon. The Moon has no plate tectonics. Its crust is a single solid shell that hasn't moved or shifted in billions of years. And while we now know there's water ice at the poles, the Gruithuisen domes formed in a bone-dry environment where liquid water couldn't have played a role. So how did these granite-like domes form? It's what scientists call a known unknown. We know the question, but we don't have the answer yet. Blue Ghost 3 will deliver instruments to the Gruithuisen domes to study their composition in detail, analyze their structure, and hopefully solve this geological paradox. The answer could reveal new processes for how planetary bodies evolve, and might even have implications for understanding the early Earth. But NASA's scientific missions are just one part of the story. While Firefly is busy delivering rovers and experiments, another revolution is brewing: the lunar mining industry. Enter Interloon and Astrolab, two companies that represent the pivot from pure science to resource extraction. They're not going to the moon to study it, they're going to mine it. Astrolab is developing the Flex rover, a large, versatile platform designed specifically for lunar resource operations. This isn't a small science rover. It's an industrial vehicle capable of carrying significant payloads and conducting serious prospecting work. Interloon has a specific target in mind: helium-3. Helium-3 is an isotope of helium that's incredibly rare on Earth, but relatively abundant in the lunar regolith, particularly in titanium-rich regions. It's been deposited on the moon's surface over billions of years by solar wind particles embedding themselves in the dust. And Interloon plans to use reliable landers, like those built by Firefly, to transport their mining equipment to the moon and bring helium-3 back to Earth. So why mine helium-3? What makes this isotope worth the enormous cost and effort of establishing lunar mining operations? Two words: fusion energy and quantum computing. Helium-3 is one of the most promising fuels for nuclear fusion reactors. Unlike the deuterium-tritium fusion that most current experiments use, helium-3 fusion produces almost no radioactive byproducts. It's cleaner, safer, and potentially more efficient. We don't have working fusion reactors yet, at least not ones that produce more energy than they consume. But when we do, helium-3 could be the fuel that powers them. And the moon has enough helium-3 embedded in its soil to potentially power human civilization for centuries. Helium-3 is also valuable for quantum computing applications, where it's used to create ultra-cold environments needed for certain types of quantum processors. Interloon has already signed contracts with the U.S. Department of Energy and with Maybell Quantum, a quantum computing company, to supply helium-3 once their operations begin. Here's what makes Interloon think they can succeed where others haven't even tried: a patent-pending technology that uses 10 times less power than conventional extraction methods. Mining on the moon is brutally hard because power is scarce. Solar panels only work during the 2-week lunar day, and nuclear power sources are expensive and politically complicated. Any mining operation needs to maximize efficiency and minimize energy consumption. Interloon's process, details of which they're keeping proprietary, somehow extracts helium-3 from lunar regolith with a fraction of the energy that conventional heating-based methods would require. If their technology works as advertised, it could be the breakthrough that makes lunar mining economically viable. They aim to be the first U.S. commercial mining operation on the moon, beating both international competitors and other American startups to the punch. But Interloon's ambitions extend beyond helium-3. They've identified a broader resource portfolio they plan to extract from the moon. Industrial metals like aluminum, titanium, and iron are abundant in lunar regolith and could be used to build structures and equipment directly on the moon, eliminating the need to launch heavy construction materials from Earth. Rare earth elements used in electronics, batteries, and advanced materials are also present on the Moon. Mining them there could reduce pressure on Earth's limited rare earth deposits and eliminate the environmental damage caused by terrestrial rare earth mining. And, of course, water, locked in ice form at the poles, is perhaps the most valuable resource of all. Water can be split into hydrogen and oxygen for rocket fuel, used for drinking and agriculture, and serve as radiation shielding. It's the foundation of any permanent human presence on the Moon. Interloon sees itself not just as a mining company, but as an enabler of long-term lunar habitation. By providing the resources that future moon bases will need, they're helping to build the infrastructure for humanity's expansion into space. And this is where everything comes together. Reliable landers like Firefly's Blue Ghost are the key that unlocks the entire lunar economy. Without dependable, affordable transportation to and from the Moon, none of these ambitious plans, scientific or commercial, can happen. NASA's partnership with Firefly isn't just about landing rovers at the South Pole or deploying radio telescopes on the far side. It's about proving that regular, routine access to the lunar surface is possible. That you can send valuable payloads to difficult locations and trust that they'll arrive intact and operational. Every successful Firefly mission builds confidence in the commercial lunar transportation industry. Every payload delivered is evidence that we're past the era of expensive one-off government missions and into the age of commercial spaceflight. Interloon's mining plans depend on companies like Firefly succeeding. Astrolab's rovers need reliable rides to the Moon. Future lunar bases, scientific stations, and industrial facilities all require transportation infrastructure that works. The phrase, "There's gold in them hills," launched California's gold rush in 1849. Today, we can say with certainty, there is money on the Moon. Water ice that can be converted into rocket fuel. Helium-3 that could power fusion reactors. Industrial metals for construction. Rare earths for electronics. And above all, the scientific knowledge that comes from studying our nearest celestial neighbor up close. The race is on. Companies are investing billions. NASA is placing its bets on commercial partners, and Firefly Aerospace, with its proven track record and ambitious roadmap, is positioned at the center of this new lunar economy, from the treacherous South Pole to the radio-quiet far side. From mysterious volcanic domes to the dawn of industrial mining. The Moon is no longer just a destination. It's becoming a frontier. Firefly's Blue Ghost missions are writing the first chapter of this story. Each landing teaches us more about how to operate on the Moon. Each rover deployed extends our reach into unexplored territory. Each scientific instrument reveals new secrets about our cosmic companion. And behind the science missions, the economic forces are gathering momentum. Mining companies securing contracts. Rover manufacturers designing industrial equipment. Energy companies betting on lunar helium-3. Investors calculating returns on lunar real estate and resource rights. This is how humanity expands into space. Not with flags and footprints, but with landers and rovers and mining operations. Not with symbolic gestures, but with sustainable economic activity. NASA and Firefly's partnership represents something historic. The moment when lunar exploration transitioned from Cold War competition to commercial opportunity. When going to the Moon stopped being something only governments could do and became something that companies, and eventually, perhaps, ordinary people, can participate in. The South Pole mission in 2029 will be a defining moment. If Firefly succeeds where others have failed, if those rovers find significant water ice deposits, if the scientific instruments reveal valuable data about the Moon's resources, then everything accelerates from there. More missions, More companies, more infrastructure, more people working toward the goal of permanent human presence on the moon. A new era is beginning, and Firefly Aerospace is helping to lead the way.